Hello and welcome to a new video about Punnett Squares. Punnett Squares are a useful tool to determine the probability of inheriting genotypes and phenotypes in genetics. Punnett Squares are something used to predict probability, so they're not always 100% accurate. Obviously, genetics is a lot more complex than something you could break down into a simple tool like this. However, it is a useful way of figuring some stuff out in a more general sense. So I'm going to show you how to use a Punnett square and how to do them, as well as some helpful information when creating a Punnett square. First of all, I just wanted to do some definitions for you. First, we've got a genotype, which is what alleles you end up getting genetically from your parents. So those are the actual genetic material that you receive. And then a phenotype is the actual physical trait. And the physical trait could be anything. For example, the ability to roll your tongue, having an attached earlobe, your eye or hair color. Those are all phenotypes. So let's get to the actual Punnett square. A Punnett square looks like this. Okay, it's like kind of like a childhood window. So like when you're a kid and you used to draw windows on like a house, it looks like this. Okay, and here's how you're gonna set it up. You're gonna have one parent on the top. For this example, I'm gonna put Dad up there. Okay, and then on the side, you're going to put the other parent. So in that case, it would be Mom. Not to say that, you can't have parents that aren't a dad and a mom, but, genetically, you need an X and a Y, or you need a dad and a mom to kind of make that work at this point. So we got dad and mom up there. And then you're going to want to put what you think the genotype for each parent is. And we represent those genotypes with letters. So for Dad, in this instance, we're going to put, let's say, a capital A and a lowercase a. And then for Mom, we're going to put two big A's there. Now, the reason there's kind of two different letters you can choose. Most of the traits that you're going to use a Punnett square for have either a dominant or a recessive trait. So let's say for this example, we're doing being able to roll your tongue. So the dominant trait in that particular instance is the capital letter. So that means that if you have that trait, you're going to be able to roll your tongue. And then the recessive trait is that you can't roll your tongue. That's the lower letter there. Okay. So then when you fill out the Punnett square, each one of these boxes is 25% probability of receiving those genotypes. So for instance, when we fill it out, we're just going to drop the letter down through the boxes. So this one's going to be a capital A and a capital A. And then over here, we'll drop down our little a. And then for Mom, we're going to go across. So we'll get big A here, big A here, big A here, big A here. And so now we've got a completed Punnett square. And we can learn a lot about the offspring that this dad-mom combination we're going to have. Okay. Here in this example, 50%, 2 boxes worth, are going to have the genotype AA, and then the other 50% is big A, little a. Now, these are 2 of the possible genotype combinations you can get. We've got this one, which is dominant. You've got 2 dominant traits, so you're going to get the dominant trait in our example. It'll be rolling your tongue. Here, you have a dominant trait and a recessive trait. In that case, the dominant trait's always going to win, and we call that a carrier. So you carry the recessive trait, but it doesn't actually show up. So you can still roll your tongue, but your children could potentially not be able to roll your tongue. And then the other possible answer would be little a. And in this example, we didn't have any, and that's the recessive trait. All right, so in this combination of parents, those offspring are not going to be able to have the non-tongue rolling gene, but that's okay. Okay, now we're going to do one more example, And my goal with this example is to just show all the different possibilities that you can get and how we kind of get to those possibilities. So for example here, we're going to have 3 different Punnett squares so we can show off some examples. Draw those real quick. Okay, and now we're going to show off our 3 Punnett square examples. Okay, so on the first one, we're going to have parents that have capital S, and on both sides. Camera angles. There we go. Okay, and then on the middle one, we're going to have 2 carriers, so big S, little s, big S, little s, and then here we'll have 2 recessive parents. Okay, each one of these examples, right, we're going to fill in our squares, so we're going to get big S's here. In this one, we're going to get 1 double big S, 2 big S little s's, and 1 little s, and then here we're going to just get a bunch of little s's here. So now in each of these 3 scenarios, we're going to get a lot of different probabilities. On the first one over here, it's 100% probability that the dominant trait is going to show through in the child. And it's because both parents have both alleles that are dominant. In the middle one here, because they're both carriers, there is a 25% chance that the recessive trait is going to be the trait that shines through, but 75% of the time you're going to get the dominant trait. And then over here with 2 parents that are recessive, the child will always, barring some sort of mutation, show this recessive trait. Okay. There are lots of different Punnett square possibilities, and you can explore more, I'm sure, in class or online. There's lots of different resources to look at Punnett squares, but there's a few things to keep in mind. Okay, in all cases, regardless, the parental genotype is going to be what's determining the probability of offspring's genotype. Okay, so the parents' genetic material is what's going to be causing offspring to have their genetic material. Okay, we know that roughly because of Gregor Mendel. He was a monk who experimented on pea plants, and he kind of figured the laws out that allow us to do this. So Gregor Mendel, thank you for that. And then, like I said at the beginning, genetics is really complex, and Punnett squares is an oversimplification of what all is going on in our bodies. Things like hair color, eye color, all that stuff cannot really truly be captured by a Punnett square, right? There's a lot more stuff going on about that. It's a simplification of a really complex biological process. Not to knock it though. It is a very useful tool, and it's something that you'll definitely be using and doing in your genetics class. So go ahead and take a look at this video if you're ever wanting to learn more. See ya.